All right, pre-calculus. This is the beginning of chapter 10. We're moving on to some more applications of trigonometry. In particular, we have in the past studied right triangles, but we haven't studied yet what are called oblique triangles. So in the first two sections of chapter 10, we are going to study, we're going to introduce some formulas that are going to help us solve problems involving oblique triangles. So what's an oblique triangle? An oblique triangle is just a triangle in which none of the angles are right angles. So you can see here I drew an example of a triangle where none of these angles are 90 degrees. They're all something else. There's one obtuse angle and two acute angles. You can also have it where all three of them are acute, like in the case of, for example, an equilateral triangle where they're all acute. So we, in our study of oblique triangles, are going to establish like a standard labeling of the angles and the sides. So the angles are going to be labeled A, B, C, and it doesn't really matter what order they go in around the triangle, but we're going to use capital letters A, B, C to represent the values of those angles. And then the lengths of the sides are going to be represented by lowercase a, b, c. And the way you label is that you use the opposite angle to determine how you label the sides. So the side which is directly opposite angle A, capital A, is going to be labeled lowercase a, like that. And the side directly opposite capital angle B here is lowercase b, and the side directly opposite angle C is side C. So that is going to be our standard labeling. So if we see lowercase ABC and capital ABC, we know those are talking about sides and angles respectively. And also you know that corresponding letters, so like side A and angle A, are opposite the triangle from one another. We're going to take that as an assumption. Okay, so these 6 pieces of information, 3 sides and 3 angles, these 6 pieces of information are all the pieces of information that define this triangle. But it turns out that you can solve the triangle, and solve, in this case, solving a triangle means to find all unknown sides and angles. And it turns out it's possible to solve a triangle as long as you have at least 3 pieces of information. And that it could be almost any combination of 3 pieces of information from the 6 options we've got here. So we're going to go through the different possible combinations of information you could have, and then over the next 2 sections we'll learn the different strategies, 2 formulas called the law of sines and the law of cosines that you can use to solve triangles in each of these different cases. Okay, the first case I want to address is the angle, angle, angle case. So this is angle, angle, angle. If you know the 3 angles of a triangle, then actually you can't solve it. I started with this case because this is the one case where it's impossible to solve. And the reason it's impossible to solve is because you don't know how big that triangle is. You don't know if it's small or large. And you could have the same exact 3 angles in a small triangle or a big triangle. And you would never really know which triangle you're dealing with. So it's impossible to determine any of the lengths of any of the sides. So this is a cannot solve situation. However, if we know the length of at least one side, then we can solve it. So one of the cases we're going to look at is the angle, angle, side case. The angle, angle, side case is where, let's see, I'm just going to draw a generic triangle here, is where you know an angle, another angle, and then you know a side. And if you go around the triangle, actually I'm going to call this one B just for consistency, I think. If you go around the triangle, then the order in which you encounter those things, it doesn't matter which way you go around, but there's got to be one way to go around such that the order you encounter them is angle, angle, side. Okay, if you're going around the other way, you start with B, you go angle, angle, and then side. So angle, angle, side. Okay. In particular, the side is not in between the 2 angles that you know. If these are the three pieces of information you know, then you can solve a triangle. Also, if you have one angle and two sides, the side-side angle case, the side-side angle case is something like, maybe you know side A and you know side B, and then you know angle A, like that, something like that. Okay, you have if you're going around the triangle, you have a side, and then followed by an angle, and those are the things you know. In that case, you can solve the triangle. And a third one I want to mention here is angle side angle. This is I actually should have written this one up the top. It doesn't really matter what order they're in, but I would have preferred to write them in a different order. So you know two angles, A and B, and then you know the side which is between them, which would be side C. That's another situation where we can solve it. And these three cases I've introduced so far, these three cases here can be solved with what's called the law of sines, which is what we're going to learn here in section 10.1. Okay. I'm going to put a star next to the side-side angle case because the side-side angle case is especially annoying. And so when we get to that one, it's going to be a little bit more complicated. But the angle side and the angle side angle are pretty straightforward, as you will soon see. The other two cases are side angle side. Okay, I forgot to do this part. Side angle side, where you know two sides, let's call them A and B, and then you know the angle which is between those two, so like angle C right here. Okay. So you know two sides and the angle between them. And then, of course, the side, where you know all three sides of the triangle, but none of the angles. This is another, these are both situations here which can be solved using the law of cosines, which we'll go over in 10.2. Gosh, I can't spell today. Cosines. So these are all the different cases, all right? We've gone through like all the angles, can't solve. All the sides, you can solve with the law of cosines. If you have two angles and a side, either with the side not between the angles or between the angles, then you can use law of sines. And if you have two sides and an angle, if the angle is off adjacent to the two sides, you can use law of sines. But if the angle is between the two sides, you can use law of cosines. So that's it. Those are all the different possible combinations.